We want to find the equation of a degree 4 polynomial function with real coefficients having zeros or roots x equals 4 with a multiplicity 2, x equals negative 3, and x equals 0 with multiplicity 1. The function also passes through the point negative 2, negative 36. So to find our polynomial function, we're going to find it in factored form, or the form given here below, where f of x equals a, some constant, times the factor of x minus r sub 1, times the factor of x minus r sub 2, and so on, where r sub 1, r sub 2, r sub 3 are the zeros or roots of the function. Remember, the zeros or roots are the values of x that make the function equal to 0. So we'll start by finding the factors of our polynomial function, and then we'll find the value of a using the given point. So we'll start with f of x equals a times the factor of, well, the first 0 is positive 4, so our factor would have to be x minus 4. Notice this 0 has multiplicity 2, which means x equals 4 is a double 0, so we'll have two factors of x minus 4, or we can just say the quantity x minus 4 squared. Notice if we substitute 4 for x, this factor would be 0, making the function value equal to 0. The next 0 is x equals negative 3, so we'd have to have a factor of x minus negative 3, which is x plus 3. This has multiplicity 1, so we have one factor. Notice if we substitute negative 3 for x, this factor would be 0. And our last 0 is x equals 0, so we'd have a factor of x minus 0. Now let's go ahead and clean this up. X minus 0 is just x, so we can write this as ax times the quantity x minus 4 squared times the quantity x plus 3. Now let's find the value of a, and we can do this using the given point here. If the function contains the point negative 2, negative 36, that means f of negative 2 must equal negative 36. So let's find f of negative 2 by substituting negative 2 for x, and then we'll set this equal to negative 36 to find the value of a. So we would have a times negative 2, or negative 2a, times, this would be negative 2 minus 4, that's negative 6 squared. And here we'd have negative 2 plus 3, that's positive 1. And this must equal negative 36. So we have negative 2 times a times positive 36 times 1. That's going to be negative 72a equals negative 36. Divide both sides by negative 72. And we have a equals positive 1/2. So now that we have everything, in factored form, our polynomial function will be f of x equals, let's go ahead and use this form here. So we'll have 1/2 x times the quantity x minus 4 squared times the factor of x plus 3. This would be our degree 4 polynomial function that has the given characteristics. Let's go ahead and verify this graphically. Here's our 0 or root of negative 3 and 0. Notice how the multiplicity is odd or equal to 1, so the function crosses the x-axis. And then over here at positive 4, notice how the function only touches the x-axis, it doesn't intersect the x-axis. This is how a function behaves when the multiplicity is even. So the zeros or roots of this function look good. And for the last verification, let's make sure this function contains the point negative 2, negative 36. Well, here's our point when x equals negative 2, and the y-coordinate or function value does look like it's equal to negative 36. So this graph verifies that our work is correct. I hope you found this helpful.